Hello everyone, this is Leslie Langnaw, Managing Editor at Design World Magazine, and we are here at MD&M West today, and I'm here with John Good of PBC Linear, and we're going to show you a little bit about this amazing 3DPX1000 1 meter by 1 meter by half meter 3D printer that 3DP Unlimited developed using PBC linear components. So John, if you could, take me through a little bit about what were some of the components used to create this. And by the way, this is something that any engineer could do on their own if they wanted to.
Thanks, Leslie. This is a perfect example of mechatronics made easy. If you look at the challenges of a mechatronics engineer to go ahead and address your linear, where it's long, straight, accurate, and is pre-engineered alignment. Optimized transmission, where you can go ahead and choose the optimum of speed as well as positioning with technologies such as anti-backlash lead screws that go ahead and, in this case, address print quality. Then you go on to mechatronics issues related to electronics and the ability to go ahead and use integrated steppers where the amplifier is mounted on the back of the motor to go ahead and address simplified wiring, but also address enhanced thermal management. And then finally, it's all got to go together. And so here's a perfect example where the design engineers actually use the 3D printer to address all those challenging issues related to bracketry and the things that allow somebody to implement the IKEA model, meaning that you buy the pieces but they go together well. So this is it. It's mechatronics made easy.
Now just a little bit, here is an example of one of the parts that you can make on this 3D printer. And then let's go a little bit over some of the actuators and some of the other devices that you have there.
First of all, the linear axis, what I'm holding in my hand are good examples of pre-engineered alignment, where patented processes that allow us to go ahead and make aluminum long and straight and cost effectively address linear without a lot of alignment, without a lot of fasteners. That's the foundation. But then you need to go ahead and have a transmission. And a technology that PBC has invented is anti-backlash technology called constant force, where utilizing constant force spring, we address the issues related to backlash that historically have been problematic. Imagine it's kind of like being able to go ahead and on a printer, get a great first and second gear, which you need when you're moving in very short, quick moves. And then finally, I was describing some of the examples of distributed electronics. Here we have the amplifier mounted directly onto the back of a stepper motor, complements of applied motion products. But the benefit to a mechatronics engineer is that the overall wiring becomes a lot easier, and then also all the heat is dissipated out in the free air as opposed to being in the middle of an enclosure. And then finally, as I described, bracketry. One of those overlooked painful issues for a design engineer, and imagine being able to go ahead and print your bracketry to go ahead and validate that what you need. That's how this company was able to turn 3 iterations of this design in less than 4 months.
So all the blue parts that I see here have been 3D printed.
That is correct.
Okay, I can see that you can make large objects with this, but what about small objects, and what is the print resolution for this?
In this configuration, print resolutions down to 50 microns are achievable. So here would be an example.
Okay, and thank you very much, John. Appreciate it.
My pleasure.
That's it from MD&M West for Design World Magazine.